Hey, so I want to make a video today about finding symmetric equations for a line of intersection. Last night I had a student ask me how to do this problem, and I saw this really convoluted way that their textbook showed them how to do it. So the question was this: it was find the symmetric equations for the line of intersection of these two equations, and like that kind of skips over. But like if you do a Google search for this, you find like all of this crazy stuff about finding a parallel line and getting the vector set to a point. So like all of these solutions are really complicated, and I was really surprised when I saw this one from a university. But these problems don't have to be this complicated. Like you should probably learn it the way that they're doing it here with these lines and stuff, and you could probably explain that. But really it comes down to you want to find a set of equations that intersect these 2 points, or these two equations. You want to find something that intersects both of them. So really you could just take this whole entire thing and just turn it into a system of equations. If you did that, you end up with a matrix. So we take the coefficient from x, get 3, get -4, get -4 for z, and then we could do what's called an augmented matrix. So you put our solution here, -5. This can come down to solving a system of equations. We put in 1 here for y, 1 for z, and 6. So now you have this, I guess you call this a matrix. Call that A. So if you want to find the relationship between these two equations, we can just row reduce this. So we do row reduce echelon form in your calculator. You can get this from going to the math section and then pressing math for this function, and then you just put in A. I did this in Wolfram Alpha, and when I put this in Wolfram Alpha, I entered it as a matrix. It gives you the solution here. So you get 1, 0, 0, 1, 0, 1, 1, 2. So I ended up with row reduced echelon form is equal to 1, 0, 0, 1. I hate that it does that. 0, 1, 1, 2. So when you have the row reduced echelon form, we just take the coefficient from x, and we end up with x equals 1 and y plus z equals 2. Okay, so that's the set of equations that we need, right? Yeah, this is actually the answer that the student had. I don't know if you're asked to, make this into a set of parametric equations. I guess you could do, if you want to make this into a set of parametric equations, you could say x equals 1, y plus t equals 2, and z equals t. That's a parametric equation. Why? Because now we can substitute any value we want for t. We get a value for x, y, and z. So that's going to be a relationship for the whole entire intersection. Well, I hope that was helpful, and if you want more help with this math stuff, I do tutoring. Just let me know. But I thought this was kind of a shorter way. The way that I see people do this online is the same. Look at this. What? It takes so long to find the answer in these problems, doing it the way with vectors. So just solve a system of equations, that's it.